Hey y'all, so we've looked at systems of equations and finding solutions of them when given graphs or tables. We can find solutions by graphing the two equations and finding that point of intersection, that place where x and y are the same for both lines. And so now I'm going to show you another way, and this is solving by substitution. Okay, and solving by substitution means we're going to substitute one equation into the other equation, and then we can solve for one of the variables. Okay, so a time when you would want to maybe do this, situation is, do this method is when you have either x or y isolated, meaning you have either x equals or y equals. So that's one of the things that we're going to be looking for in this lesson, and then you're going to want to be able to combine them, and then substitute the answer and solve for that variable and then the second variable, and then write the solution as an ordered pair. So example 1, it says x equals negative 3y and 15x minus 2y equals 94. So in this case, we have an isolated variable, which is the prime time to use substitution, right? We have an x equals right there, and x equals negative 3y. Okay, so that x equals negative 3y means that is what my x is. The x is the same as negative 3y. If you notice in my bottom equation, my second equation, it says 15x minus 2y equals 94. So since we know that x is the same thing as negative 3y, I can substitute that negative 3y in for x in the bottom equation and then solve for my y variable. Okay, in order to solve for either x or y, you can't have two variables. So what this does is it gets rid of one of my variables. In this case, we're getting rid of the x and leaving only the y, so we can solve for the y. And once we've solved for y, we can then go back and solve for x. So I'm going to rewrite my equation by plugging in what x equals for x. So 15, and instead of x, I'm going to do parentheses, and I'm going to do parentheses and put negative 3y, because that is what x is, if you notice. Right? And the reason why I put parentheses is because anytime you have a number next to a letter, that shows multiplication, and I'm using my parentheses to show that multiplication. And then I'm going to keep writing minus 2y, and then it equals 94. All right, so now that I have that, I can go ahead and start simplifying and solving the best that I can. So I see parentheses, that's the first thing that I'm going to do. So I'm going to do 15 times negative 3y, and then I'm going to subtract 2y there to combine all my variables, and we'll go from there. So 15 times negative 3y is negative 45y. So for negative 45y minus 2y equals 94. I can combine my y's and get negative 47y equals 94, and then I need to divide both sides by that negative 47. And in order to figure out what y is, that will cancel out. So y is the same as negative 2. Sorry, so my y value in this equation is going to be negative 2. So this is only part of my equation. Now that I've solved for y, I need to solve for x. Luckily for us, it's really easy to solve for x because it already tells us that x equals negative 3 times y, which we now know is negative 2. All right, and then from there, all we have to do is simplify. Negative 3 times negative 2 is positive 6, so x equals 6. So that is the second part. And then if you notice that very last point up there in our success criteria, I can write the solution as an ordered pair. We always write solutions as ordered pairs. So now that I know what my x and my y value is, I simply put them together to get my solution. So my solution is 6, negative 2. And there you have it. That is our solution. Let's look at number 2. Number 2 has y isolated. So it says y equals x minus 5. So here I'm going to do the same thing. I'm going to identify that I have a y equals in my in one of my equations of one of the variables isolated, and I'm going to substitute that x minus 5 in for my y value this time because it says y equals this. So rewriting the problem, 3x minus 2 parentheses x minus 5 equals 7. This one's going to be a little bit more tricky because since there are 2 terms inside the parentheses, I'm going to have to do some distribution. So I'm going to distribute this -2 to both my x and to my -5. Keep the 3x the same. -2 times x is -2x. -2 times -5 is positive 10. So 10 plus 10 equals 7. I can combine my x's. 3x minus 2x is just 1x. So x plus 10 equals 7. Subtract 10 from both sides to get x by itself. And I get x equals -3. Now that x is -3, I can go ahead and substitute that in to my original, my first equation, and say that y equals -3 minus 5 instead of x minus 5. So then that means y equals -8. Go back down to the bottom and I can write my solution there. My solution is -3, -8. Something to be aware of, okay, is which one you're solving for, okay? Don't get confused, right, when you're solving. Okay, I solved for x and then I solved for y. Last time we'd solved for y first and then x. Okay, so make sure you're keeping track of which variable you're actually solving for. And then when you're writing your solution, make sure you write it in the correct order. Remember, you always write solutions as an ordered pair, which is x, comma, y. All right, so here's just a little tip that you can kind of see here at the bottom here. Did you know that you can use your calculator to solve for your variable? You still need to substitute, but you can actually use insolve to solve for your variable. So we've learned about insolve already this year. So once you've substituted your isolated variable, that other part, that circled part on both of my examples, once I've substituted that into the second equation, I can actually use insolve to solve for it and then plug in that variable into either equation to get your second variable. Notice that I solved by plugging into my original equation, right, my first equation. So on that second one, I did y equals x minus 5. And to get what y equals, but I could have used the bottom equation, 3x minus 2y equals 7, and that would have given me the same answer if I plugged in -3. Okay, you can use either equation and it will give you the same answer for what y equals. I just chose to use the one that already had y isolated because I figured that would be an easier one to simplify. All right, and as you see, there's some tips right there for how to use insolve on the right side. And then when you're solving using insolve, don't forget to add the comma and then the variable, okay, that you're solving for. So if you're solving for y, you would put comma y. If you're solving for x, put comma x. So let's try 2 more examples really quickly. All right, I see that my variable, that my 2 equations, I have y equals 3x and 2x plus 3y equals 44. I notice that my y is isolated right there, so I can plug in 3x into my other equation to do that. So go ahead and try this one, and then check it in just a second. So go ahead and pause it and see if you can do this one. Challenge yourself a little bit. Right, this is what it should look like once you substitute. Be careful that you remember to put a 3 and then parentheses 3x, because that 3x in parentheses is really just what our y is. All right, that's the same as y. And maybe we need to make a little note of that. That is y. Right, and then I'm going to go ahead and do my multiplication. So 2x plus 9x equals 44. That leaves me with 11x equals 44. I'm going to divide both sides by 11. I get x equals 4. And let's go ahead and solve for my y by plugging in that x value. This time, let's just use the more difficult one. Let's use my other equation just to see that it does, in fact, work. So I'm going to do 2, and then instead of x, I'm going to do 4 plus 3y equals 44. 2 times 4 is 8 plus 3y equals 44. Subtract 8 from both sides of my equation. 3y equals 36. Divide by 3, divide by 3. Y equals 9. So my solution would be 4, 9. If you want to look at that original other equation, right, that would be just y equals 3 times, why did I say 9? That's funny. 36 divided by 3 is not 9. Hello, guys. Look at that. I caught my own work there. Please ignore. Let's just fix that by, there we go. Okay. 36 divided by 3 is definitely 12. So my equation is, or my ordered pair is 4, 12. Okay, and then if I wanted to see what that would look like, it would just be y equals 3 times my x, which is 4. Right? That's how I caught myself right there. And 3 times 4 is 12. So there you go. It really will work. It'll give you the same answer no matter which one. Again, I recommend using the one that is more simple, that already has that other variable isolated. It is much simpler, as you can see. All right, let's try this last one. All right, I have an x equals y minus 5, so I'm going to substitute in that y minus 5 for my x. So I have 3, not an x, parentheses, y minus 5, plus 2y equals 30. Go ahead and do some lovely distribution here to get 3y minus 15 plus 2y equals 30. As you can see, things we learned back in Unit 1 do not go away. We're still doing distribution and combining like terms, simplifying equations and expressions. So it is really important that we still know these skills and practice them. We use them all year long. So if you're having trouble doing any of these steps, I recommend you go back and look at some Unit 1 notes. Hopefully you still have those. You can kind of refresh your memory. From here, I can go ahead and combine my like terms, my 3y and 2y, to get 5y, since both of those are positive. So 5y minus 15 equals 30. I'm going to add 15 to both sides. So 5y equals 45. Divide both sides by 5. Y equals 9. And now let's find what x equals. So x equals y, which is 9, minus 5. So x equals 4. All right, this is where the tricky part. Make sure you're writing your x actually first instead of second. That would be 4, 9. All right, let your teacher know if you have any questions. This is just a simple way to solve in case we don't want to graph, okay, sometimes, or a graph isn't provided or given to us. Substitution can be sometimes a quick and easy way to find your solution. Right, remember, these two equations could totally be graphed. We could graph these and see them on a line and find that point of intersection. But this is just another way to do that if that's not the easiest option. If you see it with a y equals or an x equals, we can simply plug it into the other equation and solve for both variables. Let your teacher know if you have any questions.